Hi friends, this is Arun. In this video, we'll have a look at the basics of compiler and interpreter. So many programmers miss out the tiny details of understanding the process in compilation and interpretation. So this video focuses on that part. This is very crucial, though it looks silly. So let's start with the definition. So any compiler or interpreter, the job is to translate from high-level language to a low-level language. When I say high-level language, like Java, C, C++, Python, whatever. Okay, so low level language is only one language, which is machine code. So the job of these two guys are to convert from the high level to a low level language. That's it. Okay, so but the way they translate that to high level to low level is slightly different. The compiler takes the whole document or the whole program and then gives you the final compiled result, whereas interpreter takes line by line and then checks every line and stops wherever there is error. Okay, every time it does that, the interpreter does this, whereas compiler, it does the compilation once and produces some output. It could be error output or it could be exe, whatever they expected. Okay, so that's the difference. So what are the varieties? Like when it goes to compilation, there are a lot of compile language: Fortran, C, Pascal, Java. When it comes to interpreter, like Python, even Java is partly interpreted, partly compiled. And thousands of target languages. When I say target languages, intermediate is the assembly language. It's mostly dependent on the processor. And the final thing is the machine language, which is understandable by machine, which is a binary zeros and ones. Okay, when it comes to compilation process, the compilation process like a single pass, multi-pass, load and go, all those things, and the compiler also does part of optimization as well. Okay, like that it is overwhelming. Things inside a compiler is overwhelming, but we don't need to know all those things. All we need to know is the basic steps which is there. It's like understanding how to ride, learning how to ride a bike rather than understanding the mechanics inside the bike. If you know the mechanics, it's beautiful, it's well and good, but if you can't, at least you should know how to ride a bike. Okay, let's start with a simple requirement. Okay, so as we said, it translates from one language to another language, so that both guys understand each other, like translating from Japanese to Chinese. Here the Japanese is your high level languages, whereas the Chinese is the one machine language. Okay, so uh, when you translate to the machine language, there are different types of machines, like a processors. Okay, so all the machines need to be taken in consideration. That is one important thing. Okay, so while doing that, we took look out for two things. One is the syntax, another one the semantics. Okay, syntax is the semicolon is needed or tab is needed, so all those things. Semantics is the meaning of it. Like let's assume I have given a plus b, the compiler should know that it should add those two things. Syntactically it is correct, but if it doesn't know that it should add, instead of adding it does the subtraction, the entire thing is gone for a toss. Okay, so those are the two things will be given as a say constraint to the compiler. Okay, so these are the various steps in C++ compilation. Let's take one, and because I am picking C because everybody knows C at least in one way or other. Okay, uh, so yeah, you start with the source code. Okay, where you type in an editor or IDE or anywhere, and then you save it and compile it. When you compile it, these are the steps it does. First, it's there's a step called pre-processing. Okay, then it compiles, then it generates the assembly language. Okay, and finally links and loads it. So the linking and loading is part of the OS process. Let's look at that later. Okay, so here when you do the assembly language to linking part, that's where the machine dependency comes in. So it is translated to the corresponding machine. When I say machine, it could be translated based on the OS level or in the hardware level. It could be in the both the level it is. So when I say in OS level, let's assume I have a Windows and I compile the C code in Windows, it will generate exe file, but Unix doesn't know what exe means itself. So the format which it understands is completely different. It's a dot of file only it will understand. So this becomes machine dependent code. You can't port the compiled result to another machine. Okay, this is one important thing which you need to understand. Let's see a simple code here. So I have had a hash define max of 10, and then I am declaring a variable and assigning the max value to it. That's all. Okay, so in G++, I'm using G++ compiler. It's a free and open source compiler. You can download it. Okay, when I give a G++ with the compiler option hyphen E, capital E, what it will do is it will substitute that first max with the 10 and then give me the substituted result. If you see the code which is generated in the below, so it is like that. See, here the hash define is gone, max is gone, all it has like a main and then int a equal to 10. Okay, all it does is like a plain copy pasting. So this is called pre-processing. Whenever you define something, this is the first step it happens in C. Okay, hash define or hash include. So what it will do is it will check for the necessary thing and then clean up the code and finally give you the raw code. I mean beautiful code. Okay. Then comes the hyphen S process. So which will convert that into assembly language. So when I say assembly language, it will be translated into move, okay, jump, all those kind of instructions. So these are the instruction sets for the particular processor. And finally we give hyphen O, so which will give the final output depending upon the OS it is. So here since I'm in Windows, I'll get a .exe file, okay, which will have only zeros and ones. Okay, so but this 0 and 1 is not portable with the other guy, or sometimes this this 0 and 1 is might be dependent on another DLL. Okay, it could be on different ways. Okay, so this is the steps. First is pre-processing, second is the assembly conversion, third is the object conversion, and final is the linking. So I'm just going and clicking, typing G++. Okay, first let's go and do the edit. Here I have hash define max of 100. So instead of 10, I have just given 100. And then I am declaring a variable a equal to max and then returning 0. That's all, plain straightforward code. So let's do step by step thing. So let's first do the hyphen E thing. Okay. When we do the hyphen E thing, what it will happen is like it will substitute, remove the max and then put the value with the 100. Okay. So if you see here, the same output which I have pasted in the PowerPoint is kept here. Okay, all I did is screenshot from here to there, that's all. Okay, so I got the substituted code. So now the code is a pure code which is like a ready for compilation. So next step is going for the compilation. When I give .s, let's, okay, so here I got the compiled version. So let's open it in the Notepad++ because I like Notepad++. It doesn't spoil the code itself. So for font wrap, so word wrap is done. See here, you will find lot of instructions: move, and main, sub, endif, text, all those things, ex, okay, push, pop, all the stuffs are purely instruction set for my processor. Okay, so now I have to give this instruction set and convert that into a machine dependent code. I mean already it is machine dependent because it is generated for my processor. Okay, if I give that, so I'll get a final output. Okay, .o file. Here in the case of Windows, I am giving .exe. Okay, so let's go to the folder. We'll see the .exe file. So if we run that .exe file, we'll be able to run it. But the same .exe file, if I copy it and paste it to a Windows machine using a USB drive or whatever drive, it will not run. Because, I mean, here there is no output because I haven't printed anything, but it is running. Okay, believe me, it is running. Okay, so these are the steps which is involved for compiling a code in C. Okay, the same way, let's go to Python. All I'm going to do is like I'm going to use two variables and then add it and then print it. Where is the print? Where is the print? Print C. That's it. So all I did is like line by line I executed. It worked fine. Okay. So to give another demo, let's go to the IDE and let me put the error over here in the 2 lines. If it is a compiler, it will mostly say that error in this lines. Okay, I mean if it is in the 2 lines, because it will compile the whole program, so it knows all the errors and then it tells you upfront. Whereas in the interpreter, it will not do it. If I run it, so it comes here till then and says that I have an error over here. So the error is like forget about the syntax, that I'll fix it. So it is for compiler, I mean to knowing the interpreter. So now I have fixed the first error. If I run it, it will give me the error in the second line, next line, and it will run it. Then I'll finally get the output. If I give a letter which is like it'll say that that's a consonant or a vowel, it will say that. Okay, some of the common popular languages which is using interpreter is Java and Python. Java's two phases, like first phase is the compilation, second is the interpretation. So when you do Java C, if you have worked in Java, so first you will compile it, then you will run Java using Java and then the class path. Okay, so first half is the compilation, second half is the interpretation. Okay, so this is the thing. So to summarize, so compiler and interpreter both does the same thing. It translates the human language to the machine language, but the way it does is little different. Compiler takes the whole thing and cooks it and gives you the final result, whereas interpreter takes line by line and then does verification and finally comes with to you for each and every line. So the advantage is the speed versus portability. So if it is compiled, you will not port, whereas interpreter you can always port because it is every time compiled. But since every time it is line by line compiled or translated, it is little slower. Okay, thank you friends, bye bye.